Okay, picking up where we left off on 179, we're talking about embedded operating systems. And you've probably heard this new term called the Internet of Things. And the Internet of Things basically means that, okay, this is kind of a stupid example, but I could have, my thermostat and my alarm system and my TV and my coffee pot and all this all hooked up on the internet. And so if I'm away, I can, turn on the coffee pot or turn off the alarm or, turn on the TV or, all sorts of weird stuff. Anyway, the idea is each one of these little boxes, and they're tiny little thing. I mean, most of these embedded computers are typically, about the size of a credit card and a little bit thicker than that. But, physically they're pretty doggone small. But they need an operating system. One of the up-and-coming operating systems is, believe it or not, is a new version of Windows. Windows used to be called Windows Embedded. That's not what it's called now, but that's not the point. Is a stripped-down version of Windows that'll run specifically on these little itty-bitty guys. And it is tiny. I mean, physically. You think an operating system, when you have a naked computer and you install an operating system on it, see how much disk space it uses, you go, oh my God, look at it, it took up half my space in my hard drive. Well, trust me, this Windows Embedded guys, man, they are tiny, 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 tiny little things. And they don't take up hardly any room at all. So, point of sales units, everything, you'd be surprised. Probably in your car, there's probably about a dozen embedded computers. I mean, there's one for cruise control. There's one for the entertainment system. There's one to deploy the airbags. There's one for, the braking system, anti-lock brakes. And, there's one for, the collision control and all. And there's lots and lots and lots of these embedded computers, whether or not you see them. The example they talk about is this, infotainment. I always love that term. Infotainment system, the big screen on your TV. Okay, let's continue. The next category they talk about is what's called utility software. And utility software is kind of halfway in between. It's things that you probably don't run every day, but they're kind of there to help you. So they're kind of halfway in between, like the operating system and the application software. There's kind of a category in between. Things like, keeping track, the search function. So if I wanted to find a file and I can't remember where it is, and I fire up a search utility to find that file, well, is that an operating system? No. Is it really an application software? Well, no, it's something in between. It's a utility program. Okay, and there's lots and lots of these guys out there. I'm not going to spend... But a classic example of one of these is things like the antivirus software. Antivirus software installing on my... I have a third-party piece of software running on my computer, and all it's doing is just looking at the files coming in to make sure that they're safe. That's a good example of a utility. File compression, a zip file. So I use WinZip, and so that's kind of a nice file compression utility. Spam filters for email, and certain types of utilities for determining whether or not your network is in good shape. Those are all good examples. Then we have, server and mainframe utilities. Well, now we're getting off into the weeds here, but, if I have a system set up and I'm running my accounts payable on there, I probably need some sort of a utility that periodically looks to make sure that, my accounts are in order and those kind of things. The hardware and the software and the networking is all operating normally. One of the things that they talk about here is virtual machines. I mentioned that in a previous video, although I probably didn't describe it very well. And the idea is that I don't necessarily have to have a physical machine in order to do something. I could go buy one big server, powerful server, and then inside this server I can have 4 fake servers, 4 virtual servers. This could be my database server, and this could be my server for payroll, this could be my server for the web, this could be my server for, whatever, database and stuff. So different types of servers, but they're not real. They're as real could be, but you just can't touch them. They're virtual. Okay. Again, I probably didn't describe that well enough, but too bad. We kind of get what we're after. All right. The next thing to talk about is this whole concept of middleware. Now, middleware, page 184, middleware used to be big business. And the idea was, I had an IBM mainframe over here, and I had a PC over here, and I wanted to connect the two together and transfer data. And this was kind of proprietary database over here that didn't exist over here. So I really just couldn't connect. I needed something in the middle, a translator. So the way I look at it, this is like the universal translator. I put something into the pipe, it translates it and goes to the big boy. The big boy sends something back down the pipe, the guy in the middle translates it and sends it back. So the universal translator was very, very important at the beginning when all these systems were kind of disparate. That's not normally the case now. Now everything is kind of standards based, and so almost every database on these big gargantuan mainframe computers, all these databases and other applications can talk standards, and practically anyone can connect to them without the use of any middleware. And the way I talk about it is, if your business is middleware, man, I'd be looking for another job, because I'm thinking that the middleware business, the whole industry as a whole, is getting ready to crater if it hasn't already. The next thing to talk about is service-oriented architecture. And a lot of companies have been doing this for quite some time. You've probably heard this. And the idea is that in order for me to sell my product, I want to be able to tell you that I'm going to have an agreement with you that basically says I'm going to be up 99.99% of the time, and I'm going to do this, and I'm going to do this. And so it's going to be like a service agreement. And the idea is that I don't need to be talking about how many gigabytes and megabytes, because those are kind of things in the weeds. Instead of talking about the hardware specifications, I don't talk hardware. I talk service. I'm going to guarantee so many transactions per second. I'm going to guarantee you so much bandwidth. But how I do that, that's not all that relevant, is it? And this really became about when virtualization came. Because if I had an agreement that said, well, I need 4 meg RAM and 2 cores, well then if I was selling you a system that had 2 virtual cores and a shared chunk of 4 gig of RAM, well then that'd be a little confusing, wouldn't it? So this whole idea of don't talk about hardware, talk about service is kind of the way it works. Okay, let's continue. So now we're back talking about application software one more time. So that whole discussion was about, the system software. Application software is all about solving one of your problems. This is stuff that you run, and you want to solve a problem. You want to surf the net. You want to run a spreadsheet. You want to create a document. Those kinds of things. So I'm going to skip through this kind of quickly, as you can probably imagine, that this is just some examples of application software. Now the next category we talk about is 2 different types. They have proprietary software, which means the company sells the software, but they're not gonna let you peek behind the covers to see how it works. Off-the-shelf software is software that you just go to the store, you buy it, install it, and go on about your business. So one-of-a-kind software that's specifically designed for just a single task, and it could be, for example, that I'm producing this. I'm producing my own software. I have my own in-house staff, and they're producing this piece of software, and they don't sell it to anyone else. It's just ours, okay? Versus going to the store and just buying something. All right, so this is a very cool little chart here, this table 4.5, and there's lots of good information here. Hint, hint, hint. That might be stuff for a quiz that talks about the advantages and disadvantages of these 2 major approaches. So instead of calling it proprietary, why don't we call it homegrown? Okay? So homegrown software. Advantages: you get exactly what you want. Not more, not less. You get exactly what you want it, precisely the way you want it. And because it's being built by your own team, You get to be involved in the development, and you can have some control over the output. You can say, no, that is not what I want. I want this instead. So that's good stuff. And yes, once you've got it, you may have some features and you go, I said I wanted this, but after we've used it around, I changed my mind. I don't want that. Could you fix that and do it this way instead? So those are all good advantages. Now let's talk about disadvantages. It might take 6 months to get you this piece of software, maybe a year. Now, are you willing to wait that long? Because, if you just went to the store and bought some software, it'd be over in an afternoon. Okay? The in-house development staff you may have reached their limit, either their technical limit or their scale limit. In other words, there's only 4 of them, and you can't go to them and say, I want another project. They go, there's only 4 of us, and we're already working, full steam now. We can't do any more. And then, of course, the next one is, the features and performance of software, has yet to be developed. Could put you in, words, add this new feature, and you wouldn't really have a clue, that it's going to speed things up or slow things down. All right, let's contrast that to commercial software that I buy off the shelf. So instead of homegrown, the advantages is it's relatively low cost. This is going to cost you money. I mean, having a staff of programmers, that's expensive stuff. So lower cost because, the firm's going to spread the cost over all of its customers, not just you. Software is likely to meet most of the basic needs. There may be a couple of things that it won't do, but 90% of it it'll do. And the package is likely to be of high quality because lots of people are using it and they're finding bugs and are fixing it. The disadvantage, an organization might have to pay for features that they don't want. In other words, I have to buy this big thing. Now, I only want this piece over here, but too bad, I got to buy the big thing. So I got tons and tons and tons of features that I'll never use. And the software might lack some important feature, which require me to go back to my in-house people and say, look, I know I bought this piece of software, but could you add this feature to, somehow? And then the last one is the software might not match your current stuff. In other words, I have a particular, office suite, and then I go buy this other piece of software that's designed to, and it has to be designed to plug into that particular office suite. If I buy the wrong one, it won't plug into the thing. Okay, so those are the pros and cons of how to acquire software. All right, I mentioned to you before about key questions. Will the software run on the operating system and hardware? Now, typically hardware is not part of the question anymore. And so when I go to the store, does it run if I'm in the wrong aisle and I pick up this cool little piece of accounting software that was designed for Windows and I take it home and put it on my Mac, I'm going to be upset, aren't I? Does the software meet the essential business needs? Have you figured out what the business needs are? Is a good question. And then, is the software manufacturer, a fly-by-night organization? Are they going to be providing me services if I have problems? And what's the total cost of acquiring it, installing it, and then is there any reoccurring cost? I mean, I've had software where I think, that's a pretty good price for that, and then I read the label and it says, well, yeah, but it requires $100 a year subscription. I go, whoa, okay, no, I'm not doing that. Okay, so let's continue. Good stuff. So it's not necessarily just black and white. It's not necessarily just homegrown versus commercial off the shelf. Often there's a hybrid of the two, where you buy a piece of software and then maybe you go get a third party or maybe in-house. You just add this one tiny little feature onto it. So it's not just cut and dry. You can mix and match to some degree. Okay. This is a good place to start for the 15-minute mark. We'll pick this thing up again in just a few.